We're going to continue our Pytorch convolutional neural network. We're going to build a LeNet. It's going to be great. We had some challenges at the end of last stream where we're trying to get data going through the model. I figured it out. It was only a few little bits and pieces. Not a big issue. The input layer needed to be the right size. We were missing an extra dimension, so we added extra dimension there. We were also not inputting a batch with our input data, so we add an extra dimension for the batch because we've got one color channel and a 32 by 32 picture image. That's what we're doing there. Continue our CNN that we had a problem with at the end of last stream. We're gonna fix it though. We're gonna fix it. So I believe we could go print out. Wait, are we already printing here? We're returning out already. Okay, and we are printing it here. Good. Okay, we don't need to use dot forward anymore because we updated our model to use the base model for neural network that allows you to use the dunder method. That's called it's the double underscore method called callable or call. It allows you to execute this forward function automatically when you call the class name. So we don't have to call class. Let's see if that runs. Let's see if it runs here. Oh, whoops. Wait. Oh, okay, there we go. Name the file wrong. All right, so we got a problem. Oh no, I thought I fixed it. Wait. All right, let's see here. Return out. Okay. I thought we fixed it. Hello, sir. How's it going there? Fozenkind, good to see you. Welcome on in. Good to have you here. We're gonna get ourselves a working convolutional neural network today. We've got enough time to do it. We do. We've got enough time. So we should be able to get it to work. Oh, it's not because I deleted something. Okay, there we go. We need to get the batch in there. So we've got the batch dimension here. Let's comment this so you can see what's going on. All right, so we've got our batch, our color channels, and our width, and our height, right? So that would be B equals batch. So let's see if it runs now. Let's see if it runs without crashing. All right, so far so good. Let's go to the next level. Broken here. Did we fix this part right here? We might have. We might have fixed that part. Let's try it. Let's try it. Did we fix it? Yes, we fixed it. Okay, thank goodness. I was worried about that. I'm like, it might not be working. All right, so can we go to layer 2 now? Can we do layer 2? We should be able to. Once it gets past the first layer, we're good. And then the final layer. Do we have linear layer 3? All right, let's do that. Linear layer 3. There we go. So that's going to give us a classification of 10 possible classes. So we'll be able to train this model on 10 possible classes. I would like to say self.classes equals 10. So that way we have it set up. Let's get back to our coding here. Thank you for the party poppers. Appreciate it. All right, do we have all our number classes out there? Yeah, we got everything good there? Okay, so we fixed that. That's good now. That's all clean. Hey, there we go. Nice and easy. So we're going to be fitting data based on this format. As you can see here, kind of zooming in a little bit. We have our batch size, our color channels. We're going to have one color, grayscale, right? The width and height. There we go. Let's do it. Let's do it. So I think we're good to go. So we don't need, this should print a much smaller screen now. Yeah, there it goes. Do we have transforms? Okay, so this is what I'm familiar. All right, so import torch vision. So we got torch. All right, do import torch vision. We're gonna load the data, right? Torch transformers. Import torch vision dot is it torch transformers like that? As transformers or transformers. There we go. And we're going to specify 2 transformers. So we're going to have a composition transform. We're going to convert it to a tensor, and then we're going to grayscale it, I believe. Let's find out what the normalize is going to do. Adjust the values of the tensor so that the average is 0 and their standard deviation is 1. So we're shrinking that down to 0 to 255, down to 0 and 1, right? A little teeny tiny. So that way, most activation functions have the strongest gradients around x0. Oh, hey, look at that. So we know what we're talking about here, right? It's all about the activation functions. That's why we want the numbers between 0 and 1. So centering our data around here can speed up learning. The values passed to the transformers means first the tuple and the standard deviation, second tuple of the RGB values in the image dataset. You can calculate these values yourself by running these few lines of code. All right, let's do it. We're going to, where's the composition? All right, so we're going to do this transform here. Let's do this transform. we could do that here. I kind of want to do it right here. Self.transform equals was a transformer. Transformers.compose. Compose like that. Let's go to the next. Okay. And I believe it's an array. Yeah, so we're going to do an array here. And then we'll end the array like that. I like doing it this way. And this will be a ToTensor. Transforms.ToTensor. Like that. And then we're going to have a transformers.normalize. Let's keep building our convolutional neural network. Let's build over what the values are going to be. A whole bunch of numbers. Do we really want to type those numbers in, or should I copy paste? Oh, heaven and what? Sorry. I will paste it here to you in chat. Here we go. Copy and paste that. Here we go. All right. So this is YouTube Studio Music. Here, so you can see what I'm looking at here. YouTube Studio Music called Heaven and Hell by Jeremy Blake. There you go. Can I edit that? No, that's fine. So let me type that better. There you go. Thanks, man. Yeah, you're welcome. Alexander, absolutely happy to help. Let's copy and paste these numbers because I don't want to type them in. we don't need to spend time typing these numbers in. They're just normalization numbers for 3 color channels converting down to 1 color channel, I believe. And I was expecting that this is going to be... Okay, so the values passed through the transforms are the means, first tuple, and the standard deviation, the second tuple, of the red, green, blue values of the images in the data set. You can calculate these yourself. All right, so this should transforms.compose. Yes, exactly. I believe this is just going to convert our red, green, blue to 1 channel. I'm pretty sure. Let's find out, shall we? We will do this. Train set. La 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 la. Torch stack sample. What's this part here? Okay. Utils data concat data set. Compose tensor. Let me just read through this real quick. Okay. So we're going to download this data set here. All right. So this is going to be the data set that we're going to load. This will be the train data. And we are going to transform that. Is this transform? Okay. Okay, let's do this. All right. Let's grab this data set. All right. Import our torch.utils.data. And this is going to be from, I believe. From import concat dataset. Okay. This is going to give us access to the test data, which is really great. The full data set of just a bunch of images, which is really nice. Most frameworks, they don't include really compose. Is this not correct? Am I doing it wrong? All right, I'm going to try running it. Oh, yeah, you're right. No module name transformer. Okay, so transformed. Thank you. Now we figured it out. All right. It only took us a few seconds there. Thank you. Thank you for that. Appreciate it. Okay. Look at that. Fixed. All right. There we go. Now it should be good. All right. Now we're good. No errors. No errors. Oh, no. Wait. Oh, we got another problem. All right. We know where that is. We know where that is. No worries. No worries, you guys. Right here. Wah-pa-pa. There we go. There. Better now. Now it's going to work, right? Now it's going to work. Yay, there we go. There we go. Okay. Thank you, you guys. Appreciate it. That's awesome. Okay. All right. Let's load our concat data set here. Where is this? We're going to... Wait, are we going to use this ever? Hold on. Oh. Stack all train images together into a tensor of a shape. Oh, wait. It wants us to load all 50,000 images in one giant batch? Really? I suppose we could. Why does it want us to do that? This is really weird. It's unexpected. We don't need to do that. I suppose get the mean of each channel, get the standard deviation of each channel. Okay, for what purpose? What are we gonna do with that? Are we gonna use that, or are we just gonna do it for fun? Is there any purpose for that? Or we're gonna go our training data. So let me get this back to where it needs to be here. All right, good to go. Okay. So we're going to go train set. Train set equals, We're going to torch vision, right? Torch vision dot. What's the YouTube survey music doing here? It's Creative Commons music that allows me to stream it while you're watching right here in the YouTube studio. It allows me to do that without having any copyright issues. That's what. Let's do this part right here. I want to remember it. Datasets dot CIFAR10. Okay. And we're going to say root equals .forth data. And then we're going to say download equals true. And we're going to say train equals true. And was there something else? Oh, transform. Transform equals. Did we do this? All right, we gotta do a temporary. We need more stuff. We need the transform here. Let's do the compose. Let's just do a quick copy paste on this. So we're gonna grab that. And we're gonna put this here. There we go. Transform. Okay. Bring it over there. And we are going to set that here. Oh, is there an extra comma there? That is perfectly fine because it's Python and you can do it. Transform equals transform. There we go. Yes. There we go. Okay, perfect. Nope. Yep. What with the too many copy and pastes? Let us run this data through our standard std equals. Let's do this in the mean as well. So let's do dimension 0, 2, and 3, which is going to be, we got the batch data. Oh, we got to stack the data first. Do we really have to stack the data? Okay. Calculate our numbers, torch.std, and we say x, comma, what do we do? Yes, mean and exactly the same. Okay, let's print those out. Print, we'll do a printf here. We'll do a printf, an f print. So this will be std equals, and then we will do the same thing with our mean. Here, okay. Mean, there we go. Now if we run this, we're continuing our PyTorch journey, becoming experts. And we just discovered the source of those fun numbers that you might see floating around when you normalize data sets. Look at that. If you have ever seen normalization coming out to you before, and you wondered how they got to those numbers, that's how you do it. Noob question probably. Is there a difference between PyTorch and Python? Yes. Cathix, yes. So Python is the language. Python equals language, right? Equals the programming language. Equals programming language. And then PyTorch equals framework for Python to build AI models. PyTorch, and I didn't spell. All right, so let me spell it out a little bit more for you. PyTorch is also a C library. It's a C++ library that has bindings that work into the Python language that allows you to call this compiled, very fast and efficient C++ code directly in Python. That's the PyTorch part. So it's got an underlying high-performance library that you can use in a nice, fun, easy language like Python. Thank you for the hearts, you guys. Appreciate it. Okay, let's keep on going. So this gives us, how about we do a fun thing? How about we manually calculate these numbers when we generate our transform composition inside our LeNet directly? You might not have to do it like this, but we're gonna do it anyway. We're gonna do this anyway. All right, let's do this. We're going to create a new function now, def norms, normvex self, and we're going to put this code here, right here, you guys. We should also grab the training set. Perfect. Okay, look, wait, no, no, almost. How is it possible to run the C code in Python? It's actually a library that's, so it's already compiled. And your Python runs through either an FFI, so foreign function interface, that allows you to call code from that compiled library. It gives you access to function tables, which have memory addresses or code execution addresses that allow you to pass in data pointers and registers that has a nice little sort of interface when you call functions. And you learn assembly language, essentially. When you call a function, you put data into registers, into CPU registers. and those registers will be able to be used inside your C code. So you can say in Python, you put some functions in some. So we are going to load our data, which we have. Ooh, train data, batch size, shuffle true number of workers. Oh, we need a loader. We're going to grab the loader now. Okay. What would be great is if we could also load this self dot. Let's do this. So that way we have it. Equals. There we go. Okay. Are you making a switch function of torchlight? A switch function? This is just very basic Pytorch stuff. I don't know what to say. This is Python torchlib torch library. It is an AI machine. We're gonna see if we can fix our code here. All right. Okay. Let's see if we got that working. Nope. Where are we at here? Line 61. Okay. Train dataset transforms. Self.transforms. Transform. Ah. It's right there. Right there, you guys. It's right there. This is perfectly fine. Right here. Why is that not good? Ooh, the game maker language. Oh, yes, the game maker. I know about that. I've never used it though. Shout out to Kyle. Yeah, absolutely. Good memory, Kyle. Good memory. Okay. LeNet object has no attribute transforms. Transform. It does because I gave it one. I gave it one. Do we have that here? Do we say self? Yes. Self.transform is right there. How about this? We'll just do this. We'll make it a little bit easier. Okay, how about that? Oh, is that better? We got rid of line 61. 61, GG. Ah, here we go. Okay, that's what, all right. Now we're good. Can I bring it back? Hey, look at that, no more errors. Hey, all right, progress. Okay, so now we've loaded our data. We've loaded our data set, and we got our data loader, and we got our transform. Hey, we're making progress. It's gonna be called data loader. Where's the show image? All right, make grid. Okay. Image equals something. And then we're gonna say np image equals mg.numpy. Okay. If we want to do that, we sure do that. Plot show image np.transpose plt.show image np.transpose. Why do I have to do transpose like that? Why can't I just do .t? All right. np image. No. np image, comma. And then 1, 2, 0. Okay. Do we do, that's it right there? We don't need to say a plot.show. We just straight up do that. Is there anything else? Okay. Oh, look at that. We're gonna get a grid of 4. Okay. So that's what we're doing. Okay, got it. Is that here? Torch data, batch size shuffle. Yeah, it's on the data loader. An attempt has been made to start a new process before current process finishes. Okay. So let's get rid of the number of workers. Where's that at? Num workers. Let's get rid of that. How about that? Let's see if that does the trick. Because, yeah, all right. Hey, look at that, all right. Delete that, we don't need that anymore. Using C concurrency problem. Oh, okay, so has no attribute show image. Okay, the plot. Did I type it wrong? All right, import matplotlib pyplot. Matplotlib pyplot as a plot. And then, okay, plt.show image. Am I typing there? Oh, I am show. Okay. So just got, I'm typing it wrong. Okay, perfect. Add an issue here. Let's read this. All right. I'm just going to copy and paste this. I really want this to work. Okay. Blah, blah, blah. NP image. NP image looks good. Yeah, we copied it perfectly. We got it all aligned perfectly nice. All right. NP image, numpy image, image to image. We got to make a grid of the images. Print images dot shape. I think that's just like this right there. And then, oh, here we go. Okay, this is a problem right here. Okay. That's what we're doing. That's what the problem is. All right. We figured it out. We figured it out, you guys, just by looking at the screen. Okay. Yeah, let's make it pretty. Okay. Okay. Here we go, you guys. Here we go. Here we go. Are we going to see pretty images now? We're got to clean some stuff up real quick. There we go. Okay. Now we're going to see pretty images. Okay. Oh, pretty images. Where's my pretty images? Why did it just close out? What happened? Well, at least it didn't crash that time. Why is this not working? Where are my pretty images at? Okay. Why is that not showing? plt.ims show. Nothing's showing up. Are we missing something? Do we say plot.show? plt.show? We can do that. Did you play Resident Evil Requiem? Oh, Requiem! It's on my list. Hey! Look at what we just did, you guys. We succeeded. Boom! Right there. Look at that! We succeeded! Hey! What is this? That looks like a horse? That kind of looks like a deer. That looks like an airplane? Maybe this is a boat. This is a boat. Okay. That's a boat. We did it, you guys! Look! We got data to show on the screen! Why did it take us so long to do that? It's because this stuff is complex, right? There's some complexities to it. Yeah! We did it! Come and check it out! Let's get some more random. And look, there's a bug. Look there right here. Check this out. There's a bug in the tutorial. There's no plt.show. It's a bug. We found a bug in the tutorial on the Pytorch website, right? This is Facebook. This is Meta. This is their technology. On their website right there, there's a bug right there. We found a bug on the tutorial. How many bugs have we found so far in the tutorials? Quite a few, actually. We found quite a few. This is like bug number 4 or 5 at this point. So let's print out our labels really quick so that way we know what things are looking like. So that way we should see the actual values represented in our photographs. And then we will call it. We will call it. We're good to go. Let's print out our labels. Let's do this. Okay. So print the class self. No. Labels. Let's go labels. Labels. Let's print out labels like that. Let's print them out like that. Okay. We'll see if we can align them. They might be integers. So we're going to, yeah, they are integers. All right, they're integers. All right. So we got a car, whatever number 3 is, a frog? And what's this? Is it another boat? I don't know. If you want to do something cool, do np.mean on axis 2. Wait, what? Zachary Hamilton? Zachary Hamilton, what do you mean? np mean on axis 2 for what? The image? Oh, to do that on the image. Okay. Mean axis equals 2. Like that? Yeah, okay. All right, let's find out. Let's see if the images look prettier. Is it gonna work? Is it gonna work? Is it gonna work? Oh no, we got an error. It doesn't like that. Axis does not match array. Okay. Let's try axis 1 then. 1. We'll try lowering the axis down a bit. It might draw lines. I think it's just gonna draw lines. Okay, didn't like that. How about axis 0? Okay. No, we're gonna get axis 0. I don't know. We're gonna find out. No, it doesn't even like. How about if we don't do any axis? Like that. Wrong spot. Oh, wrong spot. Okay. 1 second. Out dimensions. Axis mean. Where to put this? On the. Tell me, Zachary. Tell me where to put this. While you do that, I'm going to grab my labels and we're going to do a self.classes. Okay, so we're going to load this and we're going to say label. The plan is for tomorrow, we're going to train. Mine says 87. Hey, crazy mess up. Good, thanks for chatting. Okay, you guys, plan for tomorrow. We're going to be building a CNN and we're going to train it. So we built the CNN. Now we're going to do the training part. We got the data in the right shape that we wanted. And let me double check. Let me double check. Wait, don't go anywhere yet. Don't go anywhere. Hold on. Let's make sure it looks correct. Okay. Is this right? We got everything good? Oh, no. Oh, no. Where do we do it? We made, here, let me just undo everything. Right here. All right. Like that? Okay. All right, let's try that. Now we should be back to normal. Now. Okay, are we good to go? Yes. Hey, perfect. All right, perfect. All right, this is great. Let's zoom in. Can we zoom in? All right, that's good enough. All right, so this is, what are those things? What is that? All right, so we get a bird, a plane, a frog, and a dog. There are frogs. Do you have a Discord?